Hello. In the last video, I have explained how to draw a schematic diagram of an inverter using electric VLSI and simulate it using ngSpice. If you have not gone through that video, please go through that video and come back here. Okay. So let us, in this video, I will show how to draw the layout, how to lay out the inverter and again simulate using ngSpice. We'll do post layout and post layout simulation after the parasitic extraction. Okay. So this is the schematic diagram with the we have named it as a NOT, not. Okay. So what you have to do is first go to the cell and new cell. Here you have to give or select layout and same name you have to give. It is case sensitive, same name you have to give and click OK. Layout and same name. Okay. So now you can see two files are clubbed now. You can expand and see. One is schematic, another one is within the bracket written lay. Lay means it is layout, but it is empty now. We have to draw now. For this one, the components will be different. You can see here the different components are different here. In the layout, in the schematic, if you go there, if you go component, you will see symbols. Okay, but in layout you will see different layers or different contacts that you will see. And also this color, I have little bit changed the color, but in the default it will show different color. That too also in Windows there is a variation in Windows and Linux version. So that's okay. Anyhow, the color may be different. If you have installed, you might observe that color will be different. That's okay. Okay. So what you have to do is, now let us start with the PMOS. So there is an option called PMOS here. Click on that and you will get PMOS here. The convention is source is always above. So this side is source and this side is the drain. Okay. Source is above, drain is below. Okay. So what we will do, first select it and we have to give the same width and length. Let me just see what I have given in the schematic. It is 20 and 2. So here also we will select it, select the MOSFET and go to the edit and properties. Okay, object properties. So let us first name M1 and width as 20 and length is 2 and click OK. Let me check whether it is M1 or M2. M1, it is M1. Okay. So then what you have to do is, I need a contact for PMOS. So contact means you have to select P act. There is option called P act here. You select and place. Okay. And and you change its width. It is 5 written, make it 20. Okay. And what you have to do is select the MOSFET and click on the source terminal and right click on the contact, so that there will be contact. So a contact is created between these two. And now you take it near to the, you can either use mouse to move like this, or you can simply use arrow key. I feel arrow key will be more convenient, so you can easily control it. Okay. So let me, okay, you can save, and once you check the DRC, press F5, there is no error. Let me see whether if I push it near to the gate, will it give error? We will see. No. So now you have made a contact to the source side. Now what we will do, we will use a layout style where all the polysilicon or gate are vertically aligned. Okay, so what I will do, first I will select complete this thing, complete MOSFET and its contact. It should be selected like this. Using mouse cursor, you scroll and select this one and go to edit, and I want to rotate here. Totally I would like to have source on the left side. Usual convention is like this, source on the left side. So I have to rotate it in the anti-clockwise. Okay, so that is 90-degree counter clockwise. You can see now it has come to the left side. Similarly, I need one more contact for the drain. I can do one thing. I can simply select this contact and press Ctrl C and Ctrl V you press, you will get the one copy. So you no need to go again P act and vary the width, all those things you can directly take. Okay, and here also you do the same thing. Select the MOSFET, click on drain terminal and right click on this, and now okay, you can press F5. There are no errors. So that is about the MOSFET. What we will do now, I will just increase the font size of that M1, let it be 3. Okay, so that it is clearly visible now. Now I have to associate parameters, MOSFET parameters with this PMOS. So I have to name the MOSFET. So I will name it as PMOS because in the schematic also we have given PMOS. So this same step I have to do here also. First select the MOSFET, go to tools, spice, and in that set spice model. So here it is selected. So again edit its property. It is PMOS, and let PMOS and let size be 3. Okay, so PMOS. Similarly, the same procedure you have to do for the NMOS also. So I will go to the component, click on NMOS and place it here, and again name it M2, and width is 10, length is 2 lambda, and this one. Okay, now again here also source is above, drain is below, and again I would like to have source on the left. So again select this one, or first you make contact then you rotate, that would be better. So click on enact now, place it here and change its width also, let it be 10, and select on MOSFET and make the connection. Okay, so let me press once DRC, no error, and now select hold this thing and rotate counterclockwise. Okay, once I can drag it till the PMOS so that whether it is aligned properly or not I can say. So it is a little bit on the right side. Let me move it to the left side. I think here yes, now it is properly aligned. So let me take back, and similar type of contact I want at the drain also. So Ctrl C, Ctrl V, and select the MOSFET, click on the drain, right click on the contact. So now take it to the this one and press F5, no issue. Now I will change the font size of this one to the 3 so that it is visible clearly, and I have to associate NMOS. Go to spice, set spice model, write NMOS and let it size be 3. So yes, now PMOS and NMOS both are ready now. What next we have to do is we have to connect this PMOS will be in the N well, so this N well has to be connected to the VDD. So I need a contact that connects N well and metal. So for that you have to see here there is an option called N well. You click on N well and take it here and adjust its width. I can even increase. Okay, and connect your source to the VDD. So source is connected to VDD. Okay, now this is VDD and I have made this connection. Okay, similarly I have to connect NMOS is the base is the P substrate. That substrate has to be connected to ground. So I need P well contact. P well contact means P substrate to metal. So that contact I have to have here. Again increase its size. Okay, and connect drain, sorry, source of. Okay, now let us save and let me check once. There is a DRC error. Let me check what it is. How to check? Go to Explorer, open the error again. It is telling the minimum width or height error. I think this is to do with this is too much near, you can see here. So let me select and bring it down. Now let me check once again. 1 minute. Let me select this. Okay, save, and now let us once again press F5. Yes, still there is an error. I think it is to do with the if I delete this one, there will not be any error, I think. No error, still there is an error. If I delete this, then let me check. Yes, there is no error. I think the error is here at the N well contact, the height I have to increase. So previously it was 5. So this one is 20, but Y size I have to make it 7 or 8. Let me try with 8. Now let us see whether the error comes or not now. Okay, let me save and press F5. Yes, now there is no error. So fault was the height of the N well contact was less. Now again go for P well and Q. Let me make it 20, and here let me make 7, and connect it to the drain. I think it should be contact should be here. Yes. Now let me check once again. F5. No errors found. You can read in the message here, no errors found. Okay, now remaining is I have to connect gate terminal. So you can see in the schematic, you can see gates are connected together and drains are connected, and here gate, click on this and connect it to this. Okay, or you can, let me take this near to the. Always remember this resolution, if it changes, you have to set it back to the minimum, so that the you can nicely place the all components. Okay, now let me see now whether it is okay. Yes, it's okay. Now connect this gate to this gate and drain should be connected together. And now once check whether there is any error. No. Now what you have to do is you have to connect now port. In the schematic we have not named this as VDD and ground. It was by default this is VDD and ground, but in layout you have to give name them explicitly, and two more ports required, that is input and output. Okay, so what we will do now, at the input I can directly extend this one, and this node itself I can make it as a port, or better to have a poly and metal contact, that is advisable. So what we will do, we will take, there is a contact called poly and metal. This one is the metal and poly contact. Select it, place it here and connect it to the gate. Okay, or I can select this one. Okay, so this one I have to create a port, and I will name it as a. Okay, so it is now I have to, let me zoom, let me increase the font size. So now it is clearly visible. Similarly I want one more contact, that is export, and make it Y, capital Y. It is there but it is not visible. Let me increase the font size. Whenever you want to increase the font size, select it and go to the object properties. So there you can change. Okay, so Y. Okay, A and Y are named. Now I have to export this as VDD. Again export, create export, and small letter VDD you write. You can increase the font size, that is we will make it as 5, and this one as the ground, create export and call it as ground. Okay, so and select it and make it 5. Yes, now it is selected. Okay, now we have completed the layout. Once we will check F5 using any DRC, no DRC. Next there is an option called tools and NCC, and you have to press on schematic and layout. Now I have to compare this layout with the schematic, whether that is correctly mapped, whether your schematic has correctly been mapped to a layout or not. Okay, so when I press here, if there is a error, one window will pop up and it will show where is the error. Okay, if there are no errors, no window will pop up, but you will get a message in the message window saying match, everything, export, size, everything is matched. Okay, let us try now. Go to tools, NCC, schematic and layout. You can see here at the message I didn't get any pop-up windows. That means it is matched. You can see here, you can read exports match, topologies match, sizes match. So everything matched. If there is a any mistake or any mismatch, then it will show, one window will pop up and show. So let me make one mistake and see. Suppose if Y I have not created, if I delete Y, now if I go and click on NCC, you can see now it is telling this is schematic, you have 2 parts, 4 wires and 4 ports, but in layout you have only 3 ports. Okay, so you can, if you click on this, it will show which one is missing. In the layout the Y is missing. Okay, so then what you have to do is you have to go there and again create an export for that, capital Y, and you can select on that and make it 5. Okay, okay, control S, save. Once again check, no. Let me once again go LVS. Yes, there is no mismatch. Okay, now I have to extract the parasitics and do the simulation. So the same spice component here also I need. So what I will do, I will go there in the schematic, click on this one and copy, and same this you can paste here, layout, component and miscellaneous in that spice code. So I will place here, and here it is a multi-line text, and paste, and click apply and OK. So I can little bit increase the font. Okay, now it is there. So here DC analysis, I think I have copied DC analysis of the inverter. So that I have copied here. So first we will see DC analysis, then we will do transient analysis. Okay, so let me save and run spice. For that I have to go to tools and spice and write spice deck. So then it will perform the DC analysis and it will show voltage transfer characteristic. Let me check. Go to the tools, spice and write spice deck. Yes, you can see here this is output and this is input. Input is swept from 0 to 1.8 volt. You are getting it's a post layout simulation. You can even see the spice code. There you can clearly see the parasitics. So where are those parasitic capacitance and resistor? So let me show once that. Go to your folder. There the name not.spy means it is the spice code of the layout. Let me open it. So you can see here there are many resistance R0 to R12, and you have one more capacitance C0. The capacitance which you have added is here, C out Y between Y2 and 0.5 picofarad. That is the capacitance you have added, but the parasitic capacitance is here, it is present, it is between Y and 0 and its value is 1.46 femtofarad. Similarly, you have many resistance connected between different nodes. So these are all parasitic resistances and capacitance. Okay, so that you clearly can see in the spice code generated file. Okay, so let me again go to the layout. Now let us try transient analysis. So same this thing. First you have to apply a pulse. Syntax is pulse, and within the bracket you write initial value, final value, and initial delay 2 micro, and 1 micro is the rise time, 1 micro fall time, 5 micro width, 12 micro period. And here analysis is transient analysis. You have to write TRAN, the step size that is 0.1 U, and total time 20 micro. And now I want to plot both input and output. So plot V of N, V of Y. I think it is correct. Let me check. Okay, let me run the code. So spice and write spice deck, you can see here we are getting proper waveforms. The red color is the input, blue is the output. So you can see whenever input is 0, output is high. Whenever input is high, output is 0. Okay, this is about how to perform post layout simulation and also compare your schematic with the layout. And so we have covered all the design steps. Next point will be actually you can convert, or you can save your file in GDS2 format and you can send it to Foundries. Okay, so that's it. Thank you.